Here's the next question, number 52. The following discrete time equations result from the numerical integration of the differential equations of an undamped simple harmonic oscillator with state variables x and y. The integration time step is h. So the equations are given: xk plus 1 minus xk divided by h equals to yk, and yk plus 1 minus yk divided by h equals to minus xk. For this discrete time system, which one of the following statements is true? The options are: A. The system is not stable for h greater than 0. B. The system is stable for h greater than 1 by pi. C. The system is stable for h lying between 0 and 1 by 2 pi. And D. The system is stable for h lying between 1 by 2 pi and 1 by pi. So we'll begin with the equations given. The equations given are xk plus 1 minus xk divided by h equals to yk, and yk plus 1 minus yk divided by h equals minus xk. Now the question says that x and y are stable variables. So we can write this as xk plus 1 minus xk is equal to h into yk. Similarly here, yk plus 1 minus yk is equal to minus hxk. Furthermore, I am going to isolate just xk plus 1. Then we can write this as hyk plus xk. And on this side, yk plus 1 equals minus hxk plus yk. Now these two equations can be written in matrix form. That's going to be our next step. In matrix form, xk plus 1 yk plus 1 would equal to some 2 by 2 matrix into xk yk. So observing these two equations here, we will find the elements of this matrix here: 1, h, minus h, and 1. So basically, if we are to write this equation, we would write it in the form of xk plus 1 is equal to a into xk. So what we can do is find out where the poles of the transfer function of this system lies. So if we can do that, then we can see if it is stable or not. Okay, so let's work on the transfer function first. So in order to find out the transfer function, we will have to calculate Zi minus A inverse. To find the transfer function, we need to calculate Zi minus A whole inverse. Now Zi minus A can be written as Z minus 1 minus H, Z minus 1. Now we need to find out the inverse, Zi minus A inverse. So you know the basic formula for the inverse of a matrix, right? A inverse is equal to 1 by det A into adjoint of A. So we are going to use that same formula for this portion here. We would now have 1 divided by determinant of this is Z minus 1 square plus H square into adjoint of A. Now adjoint of A would be Z minus 1 h minus h, z minus 1. So this is our inverse. Now if we have to observe this, we see that the poles of this equation, look at the determinant and the matrix here. Now the poles lie at z is equal to 1 plus or minus IH. So 1 plus or minus IH indicates that the poles lie outside. It lies outside the unit circle. It is plus or minus IH, right? 1 plus or minus IH. So it lies outside the unit circle of 1. So if it lies outside the unit circle for various values of h, then it denotes that the system is unstable. The system is unstable for values of h that are greater than 0. So this is the answer. Let's see which one this matches with. It matches option A. The system is unstable or not stable for h is greater than 0. So this is the solution, and I hope it has helped.